So today we'll be looking at a very popular question. So this one's called merge intervals. So you'll actually see this one in a lot of big companies. I believe Facebook asks this one a lot, but it is very popular and there's a very important technique behind it too, which can apply to other similar problems. So it's important to understand this one. So real quick, let's look at the description. So given a collection of intervals, merge all overlapping intervals. So if we look at the first example, we have, 1, 3, 2, 6, 8, 10, 15, 18. What we get outputted is 1, 6, 8, 10, 15, 18. Because the reason we have 1 and 6 is because from 1 to 3 and 2 to 6, if we put them together, 1 and 3 goes into 2 and 6. So 3, the end of 3 right here, would go into that second input. That is considered overlapping. So if they overlap, then we merge them together. So the start point would be from 1, and then it'll end in 6. So that gets merged together. 8 and 10 is left alone. 15, 18, they're independent, so that's also left alone as well. A simpler example, 1 to 4, 4 to 5. So because the end of the first list is 4 and the beginning of the second list is 4, since they're both the same, they fall in together, so they overlap. Therefore, we get 1 to 5. So hopefully that makes sense. We're going to go look at some visuals because what we want to understand is how would we handle that in our code. So I'm going to actually go into Google search and find this image that I found very helpful. I found this image on Google and I think it pretty much sums up what we're looking for in our problem. So in order to consider something overlapping, let's say we have two different intervals. So the intervals are just lists. So we have interval A and interval B. So if interval A's end is the same or greater than interval B's beginning, so as you can see right here, they're overlapping, then we can merge them together into what it says interval C right here. So interval C will essentially just be the start of A's, the A sequence, and we'll end at the end of B interval, right? So we merge that together. So if we go back to the problem right here, so 1 to 3, 2 to 6. So that essentially is summed up with this first example right here, A to B, because 1, 3, so 3 is greater than 2 right here. So obviously there's going to be an overlap, and then 6 is greater than all. So when we merge that together, 1 to 6, that essentially is the first case that we're looking at right here. So that will get merged to C with A start and then B end. Otherwise, another example would be if A is just entirely encompasses B. If that's the case, obviously it's overlapping. So when we merge that together, we'll essentially just use A. Since A fully encompasses B, the output would just be A start all the way to A end. So it just takes over it. So these are the two cases that we have to worry about. So hopefully that makes sense. Now we're going to go and visualize this. Okay, so if we look here, we have our first input. And I didn't have enough space, but this bottom part is just the continuation from the end of right here. What we're doing here is we have this input and we want to find which of these intervals overlap with each other, merge them together, and then return the output. But one of the key things here is that our input is not guaranteed to be sorted, and that could affect the output of our problem. So we need a way to handle that. How can we have a good starting point from which we can build our answer from? So to me, this seems like the scenario where we would just end up sorting our input based on the first number. So we look at the first number of every item within our input, and then we would sort by that. Okay, so now our input is sorted, and so what are we going to do with this? Well, if we want to help visualize this, let's have a line, and this denotes the very beginning and the end. So our lowest number is 0, and our highest number is 20. So we want to see how all these inputs fall within this timeline. All right, so let's take a look at our first interval right here, so 0 and 3. So how will this look like on our timeline? So we have 0 right here, and we go to 3. All right, so there's that. Then we have 0, 1. So it looks like this. 0, 2. Have that. So as you can already see, 0, 3 already encompasses these two right here. So continuing forward, we have 1 and 9. So that'll look like this. We'll go all the way to 9. And then we have 2 and 5. So I'll start right here. 10, 11. So now this one's outside of this grouping right here. So this one will probably be on its own. So then we have 10, 11, 12, 20. So this one stretches all the way to the end. and then we have 1920. So we have one final overlap right there. So this is essentially our entire inputs visualized on this timeline. So just eyeballing this, we can already see that a lot of numbers are being merged together in this first half right here. So we have 0 to 3, that's already going to encompass 0, 1, and 0, 2. So that's going to get all merged together. But if we look right here, we have this one from 1 to 9, which that also encompasses 2 to 5 right here. The earliest starting point we can say is 0. So 0, where a lot of these initial intervals start, but then it ends at 9 right here. And so all these values, or all these ranges within here, all merge together. So this one, this one, this one right here. So because of that, because they all fall between 0 and 9, we can just merge them together. When we merge that together, our output for that specifically will look like this, because all these together get merged. So we go down here. So 0 to 9 will all get merged together. Pretty straightforward. And then this one right here is pretty obvious. So, this one's all alone. It's in between these both these inputs. So this one will be on its own. And then, let me get a different color. This one starts at 12 and it ends at 20. And towards the end, we have 19 to 20 right here. So these both overlap. So as you can probably already guess, this range will be from 12 to 20. So this is what our final output would look like. We have a total of 8 different intervals, but after everything gets merged together, we'll have 3 different intervals. And so our final answer will get an output of 0 to 9, which is the green input, and then it's 10 to 11, and then 12 to 20. And the runtime of this, well, because we sorted it in the beginning, that pretty much overshadows anything else that we're doing. And so sorting functions usually run an O of n log n. And then our space complexity, depending how we did it, it would just be O of n. Because the simplest thing to do would just be to create a list called like merge or something, and then just append all of our answers to that. So space is O of n. It really helps a lot to help visualize this problem. So during an interview, if you encounter this problem, if you visualize it like so and explain your thought process, then it goes a long way. So now that we have a visual of how this will all work, let's go translate this into code. The first thing we have to do is sort our inputs. So let's just get that out of the way. So what this will look like is, what we'll do is we'll declare a small helper function within the merged function definition. And let's call this get first, right? So this will take an element, and all it'll do is it'll return for the very first index, because we're getting a list of lists, so we want to make sure that we look at the first element in a list. What we'll do is we'll take this and we'll start our input with it. So intervals.sort key equals get first. And so this is just how I do it in Python. If you don't understand Python, then maybe understand like how the sorting function works. So with key, we're just essentially specifying a function to get the first element, and we're just doing that over every input in our intervals list. What we want to do is declare our output array. So we'll just call this merged, and so this will just be an empty list. And then what we want to do is iterate through our intervals. So for interval in intervals, essentially what we want to do is check for one of our 2 cases. So our first case will check if the merged output list is empty, because if it's empty, then we just append to it, right? Or if there's an overlap. So if there's an overlap, essentially the way we would determine that is we look at the last value, like the very last value within our merged list. So if it's not empty, we look at the last value there, and we check if that is less than the current interval's start. If that's the case, then we know that there's not an overlap, so we can just safely add this to our output list. Otherwise, if that case is not met, then that indicates that there's an overlap. So what we will do is just update the very last value in our merged output list. We'll essentially compare the max value of the very last value that we currently have, or we'll compare the last value of the current interval that we're looking at. So translating this into code, what this will look like is if not merged, so merged cannot be empty, at least for this specific case, or merged. Remember, the list is a length 2, so for every interval will be a list of length 2. And so what this is doing, -1, at least in Python, gets the very last element in our list. And then 1 is referring to the second index. So if that is less than the current interval 0, so the first value in the interval that we're looking at versus the very last value within our merged list. If that's the case, then we can safely append to merged. Otherwise, that last value, so merge -1, 1, is equal to the max of merged -1, 1, or interval 1. So again, the last value of the current interval that we're looking at, or the very last value currently within our merged output list. So this is looking pretty good. This is pretty much all there is to it. All we have to do at this point is just return merged. So let's run this code real quick and see if it works. All right, cool. So it does. Now let's submit it. Awesome. So hopefully you understand this. Hopefully you found it helpful. And with that being said, I will see you guys in the next one.